Okay, we're on. Now, yesterday we spoke about binary nomenclature, ternary nomenclature. We talked about ternary. We talked about acids. We kind of ended on acids, yeah? Now, let's begin by reviewing a little bit about acids. I didn't put any acids on the quiz. We did all binary and ternary, so let me just write down a bunch of acids. Now, for writing acids, we have two kinds of acids. We have binary acids and ternary acids. Just like these names. It means 2, 3, or more than 2. All right, ternary acids, and they're named differently. Yes? So let me just put down a bunch of elements that the charge is understood. We're going to pretend it's understood to be there. I'm not writing down neutral atoms, okay? Nitrogen, sulfur, fluorine, chlorine, bromine, iodide. All right, those are just, and phosphorus. All right, those are elements. Now, these are binary. Binary uses just negative elemental ions, not polyatomic ions. Yes? And in order to make them, you simply put H in the front, and H is always +1. So this is going to be -3, so you need to put a 3, a 2, a 3, and that's it. And then there's your acids. Those are really most of, if not all, your binary acids. Now, we know binary acids are named by the prefix hydro, very good, excellent, and the suffix ic, excellent to me, excellent. The suffix ic. So it would be hydro-ic, hydro-ic. So hydronitric, hydrosulfuric, hydrofluoric, hydrochloric, hydrobromic. That's kind of a fun one to say. Hydroiodic. That syllable. Hydrophosphoric. Good. And that's it. It's easy, right? Now, for the ternary acids, you just need to, so you have carbonate, sulfate is good. Well, give me another one. Nitrate, give me another one. Shoot me one. We did sulfate. Chlorate. What is it? Good? Is that enough? That's enough. And you take a negative polyatomic ion. You can't use ammonium. Just take a negative, right? Yeah. And then what? This one here? Chlorate. ClO3. Chlorate. That's chlorate. Yeah. So you just add H, and you just balance out the charges. So get rid of the charges. We know the charges. The charges are understood to be there, right? Of course. And then it's 2, 2, 1, 1. There it is. Now, how do you name them? You just change 8 to ic, ite to us. 8 to ic, ite to us. And there are some exceptions. If you have ide, that's also ic. For instance, I'll give you one. This is a big one, and the movies uses this one a lot. That's cyanide. You ever hear of cyanide? Yeah. So HCN. All right. So you name it. That's cyanide, but I becomes ic. So cyanic acid. That's carbonic. 8 gives ic. Sulfate, sulfuric, nitrate, nitric, chlorate, chloric. Easy? Okay. Now, what I want to talk today about, just briefly, are, we actually call them, we call the system, by the way, this is all comes from an international organization that we all agree, all chemistry students, teachers, what's the problem? All chemistry students, chemistry teachers, universities, scientists, researchers, anybody who does chemistry all over the world, IUPAC, International Union of Pure and Applied Chemistry, and we all agree on these systems, okay? Now this one is called the Roman numeral system, and I'm going to show you why it's important. And it's really, it's important, and it's not hard. It's only hard if you don't practice it. Understanding is easy. It's a little bit more conceptual than the others, but if you don't practice it, you'll never get it. Okay, now, the binary and ternary systems are predicated on one very important thing. One charge, always. Anything from group 1, plus 1. Always. Anything from group 2, plus 2. There we go, we're going to add. Okay, can you see me?
No. Very dark.
All right, very dark, but you can hear me. All right, that's enough. All right, anything from group 13 is going to be plus 3. Anything from group 17, -1, 16, -2, etc. Got it? Very important. The polyatomic ions have a constant charge. Yes? Carbonate is -2, always, now and forever. Now, however, what happens if you have two compounds? Iron 2 and iron 3. If you have a transition element, and we're only going to look at the transitions because the other ones get a little bit weird. So, the periodic table, those elements in the middle, the transition elements, they can have multiple. Chromium can have 5 different oxidation numbers. Copper has +1, +2. Nickel has multiple. So how do you know which one you have? So if I have these two compounds, you have to name them. If you name them iron oxide, you're completely wrong. It's iron 3 oxide. Iron 2 oxide. Yes? Get it? So it's an extension of, there's no different rules, the rules are the same as with binary and ternary. Same thing. However, you have to put in a Roman numeral. What's the Roman numeral? It's the what? It's the charge of the metal, the charge of the positive component. So let me give you an example. So I'll give you 2 kinds of problems on your quizzes. By the way, if you go to my chemistry site, TRC Chemistry, I have tutorials on this. Very easy. What's the problem?
Both of them are same metal.
Yeah, they're both iron, but one is iron 2 and one is iron 3.
How is the charge different?
Because iron 2 is +2, iron 3 is +3. The chemistry behind it in the bill is not important right now. It's recognizing that they're named differently. Yes? If you know how to spell a word in English, or you know the English vocabulary, it doesn't mean you can read literature yet. So it's okay to take it one step at a time. Learn the language and then learn the literature. Understood? Okay. So let's say I have 2 things. I'll give you 2 examples. I have this. I'll give you an easy one, and I'll give you 2 easy ones. Okay. What's this? This is chromium. Remember, I put it on your periodic table. Thank you for knowing that. Well, what's the charge of this chromium? What must it be? Yeah, it's got to be 2. Somebody say 2? Yeah. So it's chromium 2 sulfate. This is named chromium 2 sulfate. And you're writing just like this. Chromium 2 sulfate. And this one is what? Obviously, it's nickel fluoride. Nickel what fluoride? What's the charge of fluorine? -1, right? How many do you have there? So it must be nickel 1 fluoride, right? Yes? Say it again? What is it? I can't hear a word you're saying. You have your voice like this. Yeah, thank you. Turn the volume up. Come on. Yes. You write 1. What's your question?
Do we have to write the 1 or 2?
If you don't write the 1, it's wrong. It's worth 1 billion points. If you get it wrong, you go back to 2nd grade. Pressure's on. Pressure's on. You write nickel fluoride. You say nickel 1 fluoride, you lose all those points. 1 billion points. Plus you pay a fine of $1 billion. Big stress, okay? I understand that. If I have iron, let's say chromium 4 oxide. What's the formula? Chromium 4 oxide. What's the formula? The stock market. CrO2. It's -2, right? Oxygen's -2. So I need -4. Because this says that, doesn't it?
Yeah.
So I need 2 -2s.
And 2 plus 2 is.
So what I will do is I'll send an email out with some resources that you can look at over the weekend. Broadway, you can see me after class 2. Oh, you're talking about this?
Yeah.
Oh, that's a little better. All right, I'm a little better. So, that's all right. I feel the same way. So you can have a quiz. So let's do this day by day, guys. It's a language. This is not conceptual. This is languages. Okay, you know 4 languages. There's no reason you can't learn a 5th. Okay, I taught for years. I taught Americans who were monolingual, and it was deadly teaching them nomenclature. When I go overseas, I teach students that know multiple languages. They have an easier time with this. Yes.
So
Where's the what?
where's the 4
Where's the 4?
Oh, like it's not there.
It's right here. I know that has a +4 charge and has a -2 charge. When you write the formula, you don't write the charges in. You don't write the charges in. When you have a formula, here, look, H2O. Do I have formula? Do I have charges in there? No. I know that that's +1 and that's -2. I need two +1s. But you don't write the charges in the formula. The charges are there, they exist, and they're balanced, they 0. Okay? Have a good one.